Okay, so guys, in this video, we are going to learn some new methods about how we can find the derivatives of any functions which are given to us. And in the previous videos, we learned how to find the derivative of function using the the ab initio method or the first principle method. But that method was valid, or you can say it was appropriate for solving for the functions which contained only one variable, one independent variable, and the other one was the dependent variable, x and y, respectively. But the problem over there was that we cannot solve for the functions which were containing more than one independent variables in an equation. For example, if I just write an equation over here which contains more than one variables, y is equal to x power 4 and plus 2x cubed plus x squared. Now, this type of function cannot be derived. Derivative of this function actually cannot be found using the first principle method. So today I'm going to tell you about the theorems of differentiation. These are basically 5 theorems, and the proofs of these theorems will be uploaded separately on my YouTube channel. But for now, I'm just going to tell you about the conclusions of these 5 proofs, which are very important to solve differentiation in the upcoming videos. And by knowing these 5 conclusions and knowing these 5 conditions, you actually will become a master in finding the derivative of any function which is given to you. Okay, so without wasting any further time, let's get started. The first theorem actually says that if you are given a function that is containing only a constant, for example 5 is just a constant, then the derivative for any constant is always equal to 0. This can be 5, it can be 0, it can be -1, but it should not contain a variable along with it. What is a variable? It can be x, it can be y, it can be any other variable, okay, which is dependent or independent, right? The second thing which says, if you are given a function, okay, and the function is containing a power, okay, so if you want to find the derivative of such a function which contains a power, how you can find it? The first thing you would do is move the power towards the right hand side of the left hand side of the function, and then you can solve for the derivative using the function, and now the power would be subtracted by 1 and it would become the exponent of that function. Okay, so for example, if you're given a function which contains x power 6, okay, this is a function, it is containing an exponent. Okay, so I can simply find the derivative of such a function by n. The power should be separated. It can become 6. Then the function, what is the function? It is x, so x. Then the power subtracted by 1. So what is the power? 6, and is subtracted by 1. So 6 minus 1 is actually 5. So this is the derivative of the function 6x 5, power 5. Okay, this is the derivative of the function x6. And remember, any function which is not having an exponent above it is naturally equal to x power 1. Okay, so for the third condition, you're asked to find the derivative of two functions which are being subtracted or added. For example, if I have a function fx and it is being added to another function gx, how can I find the derivative of such a function? The derivative actually will be multiplied by both of these functions, and then we can solve for it further. Okay, so how am I going to write d by dx? And now by finding the derivative, of course this is a function, it is containing a power 1. So by applying this rule over here, and this is also containing a power 1 and it is also a function, so applying this rule over here, I can simplify these and I can add those together. Same is the case for subtraction. Okay, there's no difference between the addition and subtraction for two functions which are being added, and you have to find the derivative of those functions. Okay, and the fourth condition, the second last condition, you're asked to find the derivative of two functions which are being multiplied. You're asked to find the derivative of the product of those functions. So let's just say that fx is any function and it is multiplied by another function, that is g of x, and you have to find the derivative. Of course, the derivative will be multiplied by the whole entire thing. Now, how are you going to find the derivative of such two functions which are being multiplied? Okay, so this is a little bit typical, but if you focus on it, it would be much more easier to understand. Okay, so what is going to happen? First of all, g of x, the second function, would be multiplied by the derivative of the first function fx. Okay, then you have to add this term. This thing is just one term. Okay, and then by adding, you have to add with what the first function should become as it is, and then you have to take the derivative of the second function. Okay, and this would become second term, and by simplifying both of these and adding, you can actually find the derivative of these two functions which are being multiplied. Don't worry if you are unable to understand or dig into these concepts. So don't worry, we are going to solve a couple of different examples in the upcoming videos. So these concepts would become very much clear to you and you won't have any doubt relating these concepts. Okay. The last one actually says that if you have to find the derivative of two functions which are actually being divided. The case for multiplication was that we were taking the second function and multiplying it by the derivative of the first function. Then we were adding. So in case of division, we are going to subtract, right? And then we were this was one term, and in the second term we were taking the first term as it is, and we were taking the derivative of the second function. This entire thing is coming from the multiplication thing, right? In the fourth condition, right? This entire thing is being implied from the fourth condition. Okay, this is the second term, but the only difference between multiplication and division, the derivative of finding the two functions which are being multiplied or divided, is that in division, you have to put the square of the second function in the denominator. So the first example is actually very simple, and it says that you have to find the derivative of 3x power 4 by 3. Now remember, 3 is a constant, but it is actually being multiplied to a variable, so it cannot be equal to 0. Okay, so 3 is actually multiplied by the variable x. X is the variable over here. Okay, now I have to find the derivative of this function. So what can I do? First of all, I have to separate this 3. Okay, 3. Now the derivative of x power 4 by 3. Now I am having a function that is having an exponent. So how can I solve? 3 becomes as it is. First of all, the power, then the function is being the function, and the exponent of that function is being subtracted by 1. Okay, now function 3x power 4 by 3, but remember, you cannot put a 0 for the what do you call it, the constant over here, because the constant is actually being multiplied by a variable. So if anything is being multiplied, you cannot consider them to be two separate terms. It is actually a part of the term, and it is actually one term, so you have to solve it. Okay, and for dealing with these situations, you have to just separate the constant from the entire solution. Okay, the question says that you have to find the derivative of this function with respect to x. Okay, and you can see that there are multiple functions in this equation. This in itself is a function, this is also a function, this is also a function, and this is also a function, and this is also a function, although it is a constant. But for the derivative thing, we are going to consider it as a function. Okay, now what we have to do, we have to find the derivative of these functions with respect to x. Okay, because the x is the variable, it is an independent variable, so you have to find the derivative with respect to the independent variable given to you. Okay, so dy by dx. Okay, and now the derivative would be separately multiplied. It would be actually, and now I have to multiply this derivative, I have to apply this derivative in all of these functions separately. Okay, so what would be the result? We have the 3 by 4 was actually a constant being multiplied to a variable x, right? So the 3 by 4 would become separated from all of the things which are going to happen inside that function, right? Then we are having a power x4, right? So we have to multiply the derivative separately on this x. So the derivative of x power 4 plus, we have 2 by 3 which will be separated, and the derivative would be separately applied to the function which was x cube. Okay, then 1 by 2 it would be separated, and the derivative would be separately applied to the variable that was x square as 2, which is a constant being multiplied to a variable, so it would be separated, and the derivative would be applied separately to the variable, and again the derivative is multiplied by the last function 5. What can we see over here is that 3 by 4 is as it is. Now, this is a function with an exponent 4, right? So how am I going to deal with it? The exponent would become separated. Then x, the function, and its exponent is subtracted by 1. Okay.